And again, this is number 3. All right, so very first thing on this one is we're going to kind of back up to the unit circle and make sure that we on this chart that's here, we're going to make sure everybody understands what's going on. So if I ask you to find the cosine of pi over 3, hopefully on that one you know that you're going to go to pi over 3 on your unit circle. You're going to tell me that the cosine value is 1/2. So if I, again, in the homework, if it asks you for that one, cosine of pi over 3 would be 1/2. If I ask you for the sine of pi over 3, same location, but this time it's going to be the second number, so that should be square root of 3 over 2. Okay, so again, all you got to kind of realize, the visual once you get is that when we're doing cosine and sine, it's always the order pairs. Cosine is always the x value, sine is always the y values as you're going through these things. All right, so we'll go to pi over 2. Cosine is going to be 0, sine is going to be 1. And some of the homework questions, it's going to be just that easy. Just go to those and see what you got. Pi over 6, right here, that's square root of 3 over 2, and then 1/2. And again, hopefully the bells are starting to click that you're going, oh, if I just go here, cosine's always the x value, sine's always the y value. If you go to pi over 4, it's the exact same thing in both of them. And if you notice that if you haven't noticed this, every pi on the 4 that's on the chart, whether it's here, whether it's here, whether it's here or here, they're always square root of 2 over 2. The only thing that changes is positives and negatives, just depending on which quadrant you're in as you're going through those. So any of these numbers that we have on here, and there's not anymore, but anytime you get a pi over 4, you know it's always going to be square root of 2 over 2, and then it's just a matter of one of them may be negative, both of them could be negative, or they both could be positive. So it's just a matter of getting the signs correct. Okay, at pi, that's negative 1, 0. All right, at 330, that one should be square root of 3 over 2 and then negative 1/2. All right, now here's where we go back to what we were doing yesterday with the negative numbers. If it's negative 45, negative 45 is not on the list, correct? But what we said yesterday was if it's negative 45, we've got to have it so that everything on the unit circle is between 0 and 360. This is where we need to make it a coterminal angle. So if it's negative 45, then basically we've got to take this thing and add 360 to it. So if we do negative 45 plus 360, that's going to be 315, correct? So negative 45, that's the same thing as 315. So 315 is basically this one, so it's square root of 2 over 2 and then negative square root of 2 over 2. But again, if it's negative 45, now we're going down 45 degrees. If you go down 45 degrees, that will put you on the 315 mark. Okay, so that one is square root of 2 over 2, then negative square root of 2 over 2. Okay, negative 7 pi over 6, same thing, right? 7 pi over 6 is 210, so we need to have a negative 210. So if we do 360 minus 210, that means that's going to put us at 150, which would be up here. So then cosine's going to be negative square root of 3 over 2, sine's going to be 1/2. Okay, and if you start to notice on these, everything that's a pi over 6 on the unit circle is square root of 3 over 2, 1/2. Here's your next pi over 6. It's square root of 3 over 2, 1/2. The first number is negative. If you go to the next pi over 6, it's negative square root of 3 over 2, negative 1/2. If you go to the other pi over 6, square root of 3 over 2, 1/2. So every time you get a pi over 6, it's always going to be square root of 3 over 2, 1/2. It's just going to depend on which one's positive and which one's negative to get it in the right location for those. Okay, and then with number 9, kind of like we were doing yesterday, that 720 is not on the list, but if we make it so it's coterminal, so we get it between 0 and 360, if we subtract that, that's basically the same thing as 360 degrees, right? Which would just put us right back at the 0 spot. So that one's just going to be 1, 0. All right, and then 13 pi over 2. A couple of different ways you can do this one. You can do like we did yesterday, that if you go through your unit circles, here's the first pi over 2. So every 90 degrees is pi over 2 units. When we got to here, this was the second pi over 2. We got to 270. That was the third pi over 2. When you get back to here, that's the fourth one. So we can just keep counting. 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2. Where are we going? We're going to 13. So that's 9, 10, 11, 12. That would finish up at 13 pi over 2. So that won't go with 0, 1. And just ignore that box at the bottom there. That was a typo. Not really sure why that got in there, but that's where it is. So. Okay, so everybody okay with those? Okay, and again, the last two, those are ones you just have to keep working around the unit circle to figure out where they're going to be. Because again, if it's pi over 2, it's either 0, 1 or it's 1, 0. It's just a matter. Anything that's over 2, it's always some combination of zeros and ones. And again, it's just figuring out if it's 0, 1 or 1, 0 if we get through those. Okay, now here's where we have to kind of do some new things a little bit. All right, so now with tangent, we said tangent was going to be sine over cosine. Okay, and some of the tangent problems we can do without any problem at all. So like we do number 1, if we have to find the tangent of pi over 3, that means we're going to take the sine value of pi over 3 and put that over the cosine of pi over 3. So the sine of pi over 3 is square root of 3 over 2, and the cosine of pi over 3 is 1/2. Okay, now here's where we take it back to, and you didn't do radicals back in like 7th, 8th grade, but you did do fractions. This is where you want to keep it, change it, and flip it. So you can make it square root of 3 over 2 times 2 over 1. Good thing with that is 2's cancel, correct? Mm-hmm. Okay. So then we've got just square root of 3 over 1. So that answer is just square root of 3. All right, everybody all right there? So, and again, when you do tangent, it's always going to be two things that you've got fraction form here, and you're probably going to have to keep, change, flip on most of these. So if we do tangent of pi over 2, that's the sine of pi over 2 over the cosine of pi over 2. But we've got those two numbers right here, so we know that is 1 over 0. Ooh, here's a good question of the day. 1 over 0. What's it going to be? Is it 0 or is it undefined? Which one? Zero on the bottom is always going to be undefined. 0 on top is 0, but 0 on the bottom is undefined. Again, that's where, when you're not sure if you get the zeros, don't make the same mistake I did when I was in high school. Just check it on your calculator, do 1 divided by 0, and it tells you that's an error message. You cannot divide by 0. So it's the undefined part. Okay, so again, you get to use those calculators, so don't let those get past you. Now, here's where we're going to have to do this one. And here's where the work comes into today. If we do tangent of pi over 6, that's the sine of pi over 6 over the cosine of pi over 6. Okay, so that's 1/2 over square root of 3 over 2. And for this one, there's not enough room to do this one. So we're actually going to go on the back of this thing and show you what's going on here. Okay. so we're going to just say flip this thing over the back, and we're going to work it back here. Now, how you work this one, I don't really care if you work it out where the paper's long ways or sideways. I don't care. We're just going to work this thing out. So this is where we're going to come back to that problem of 1/2 over square root of 3 over 2. All right, and don't try to squeeze it in that little box because it's not going to fit. So just flip this thing over the back so you got plenty of room for this one. All right, we're still going to do like we did before. We're going to keep it, we're going to change it, and we're going to flip it. So we're going to make this thing 1/2 times 2 over square root of 3. And you may be going, well, what's wrong with that? Because that's still good. We get to cancel out the 2's, and we're left with 1 over the square root of 3. Okay, and then eventually one of these days they will let you leave the answer that way. But in the meantime, there is no ACT, SATs, there's nobody, AP exams, all those, nobody lets you leave that answer like that. They tell you that basically you have to rationalize, and this is our new word for the day. You have to rationalize the denominator. And what rationalize the denominator means in this case is you have to eliminate the radical from the denominator. Okay. And I think eventually this will probably be one of those things that will go away because with all the calculators, with all the computers we've got now, that it basically will do this. But if you go back to, well, you go back to when we were back in the 60s when we were going to the moon. This was one of those things that they had to do this by hand. There wasn't really enough complicated of a computer to kind of do this stuff for you. Everything was still kind of done, by hand for a lot of things. So basically, here's what we're going to do. You got a bunch of short. Here's what we're going to do to rationalize the denominator. We'll use this problem with it. You're going to move. Well, let me do this. Let me tell you what you're supposed to do, and we'll tell you what the shortcut is in this case. You're going to multiply the numerator and the denominator by the radical in the denominator. And then after that, you just simplify whatever you can do. And we'll show you this one. We'll show you a couple of them just to kind of walk you through this and give you a kind of a shortcut way of what you'll actually wind up doing when you rationalize the denominator. Okay, so let me just give you an example here. So say you had 2 over the square root of 10. Okay, so whatever problem they give to you, they rationalize. Here's technically what you're supposed to do. You got 2 over square root of 10. You've got to multiply by the square root of 10 in the numerator and the denominator. Okay, and depending on what you have in the top, a lot of times with the numerator, there's usually not just a whole lot of stuff you can do. So if it's 2 times the square root of 10, that's just the square root of 10. All right, but in the denominator, what happens when you do square root of 10 times square root of 10? You get square root of 100, correct? But what's the square root of 100? I know that's 10. So that's 2 square root of 10 over 10. And then for the non-radical part of it, where you've got the 2 over 10, that part you can just simplify, divide both sides by 2. So you can make that 1 square root of 10 over 5, or just square root of 10 over 5. There we go. Okay. So that's the steps to kind of go through if you're going to rationalize the denominator. All right, I'll give you one more of those and we'll talk about what the shortcut is. Let's say it was 4 over the square root of 7. Okay, so again, we're going to multiply by whatever the radical is in the denominator. Becomes 4 square root of 7. On the bottom, again, if we do 7 times 7, that's going to be 49. But the whole purpose of doing the rationalized part is if you do the square root of 49, that's a perfect square. That's going to bring you back to just being a 7. And in that case, those numbers will not simplify. So that would be it. Okay, now here's the shortcut. What you're going to do on those, and then you can go through those steps and do that one. But if you're all about shortcuts, here's your shortcuts. You move the square root to the top. Now this will change with some other numbers, but everything we're doing for this section and the trig stuff we're doing, this will always kind of be the shortcut you can go through. So in this case, we had 2 square root of 10. The square root of 10 wind up in the top up here in the answer. So we're going to move the square root to the top. You're going to leave the number in the denominator without the square root. So move the square root to the top, leave the number in the denominator without the square root. So same thing here. We took 2 square root of 10. We moved the square root of 10 to the top. We left the 10 on the bottom. And then the last thing you then do is you simplify if you can. Okay, so move the square root to the top, leave the number in the denominator that you're working with without the square root, without the radical, and then you just simplify what you can do from there. Okay, so if we go back to this problem we had at the top, we can go through the steps on this one, but here's the shortcut. So we've got 1 over square root of 3. So if we do the shortcut, we're going to move the square root of 3 from the bottom to the top. Now the 1 was here, so we'll kind of leave that 1 still there. And on the bottom, we're going to leave the number down here, but leave off the square root. So that's 1 square root of 3 over 3. That doesn't simplify, so we'll just leave that as square root of 3 over 3. Okay. Again, go back to one we did here with 4 square root of 7. Square root went to the top. We leave the 7 on the bottom without the square root. It doesn't simplify, so then that's our answer. Okay, so back on the front side, if you want to flip this back over now. So that was the answer we were working with on number 3? So that final answer was square root of 3 over 3. So this answer needs to be square root of 3 over 3. Okay, so for the rest of these, here's what we'll do. We won't have to write this part out, but for this part, we're going to do the tangent of pi over 4. That is square root of 2 over square root of 2. What happens when you put the same thing over itself? Everything cancels, and you just get a 1. Now again, if you did the keep, change, flip, everything cancels because your 2's would cancel, your square root of 2's would cancel, and you're left with just a 1 here. When you get to the next one for pi, if you do tangent of pi, again, sine over cosine, that's 0 over negative 1. Ooh, gotta be careful again. 0 on the bottom is undefined, 0 on the top is, there we go, we got 0. All right, now here's the great thing for the next part. We do number 6. It's the tangent of 330 So here's where this sheet comes in handy. That is sine over cosine, right? We just did that back up here, right? So it's 1/2 over square root of 3 over 2. This is 1/2 over square root of 3 over 2. We know that answer is going to be the exact same, so it's square root of 3 over 3. But, question, go for it.
It's negative.
Yeah, so this one's got a negative in it, right? So if you divide a negative number and a positive number, that makes the answer a negative number. So it's just negative square root of 3 over 3. Okay? So with 45, we do tangent of 45. It's square root of 2 over 2, square root of 2 over 2. We did that right here, correct? Same thing here. These two match up, but it's a positive and a negative. So if we're dividing a positive and a negative, that's going to make it a, not a positive one, it's going to make it a negative one. There you go. Okay, we go to the next one. This is 1/2 over negative square root of 3 over 2. Again, you don't have to reinvent the wheel because that answer is right here, right? Exact same thing. It's a positive and a negative. So the answer is going to be negative square root of 3 over 3. So once you've done a few of these, you've done all these answers. You don't have to go back and keep reinventing the wheel. For 720, it's 0 over 1. 0 on top, the answer is 0. And on the last one, it's 1 over 0, 0 on the bottom, and there we go, we got it. We know that's going to be undefined. So this will be one of those that if you do enough of these, hopefully that 0 on top and 0 on bottom, you can kind of lock it in because it's going to be there for you. All right, now here's where we got to add in a few extra definitions for this thing. So we've got these three at the end. We haven't talked about these three yet. Okay, so secant, and we'll kind of go back and forth here. So when we do secant, I'll give you the full definition of it back here. All right, so secant, that is the one that's the SEC. And secant is 1 over cosine. Okay, cosecant. On the front side is the one that's abbreviated CSC. It is 1 over your sine value. And then cotangent on the front, that's the one that is COT. This one, you actually have two different things you can do for this one. For cotangent, you can do cosine over sine, or you can do 1 over tangent, either way. So, because again, tangent is sine over cosine. So if you flip this thing upside down, you can get this one. Which one you use doesn't really matter. You get the same answer either way. It just depends on your thinking and how you want to kind of think about it. We'll probably think about cosine over sine more than we do the 1 over the tangent part. Okay, so when we're doing secant, some of these answers are going to be really easy. Some of these answers you're going to have to kind of stop and think for a minute. Flipping this thing over. So for secant, again, we're going to do, now what we can do for just a minute if you want to, and I'm going to kind of cover this one up. You can just basically cover up this middle section for a minute. So I'm going to do that. This will work. Okay, so if we're doing secant, the only thing we need for secant is the cosine value. Because again, secant is 1 over cosine. So for this one, when we do secant over here, if it asks you to find the secant of pi over 3, that means it's going to be 1 over the cosine value, which is a half. So secant of pi over 3 is going to be 1 over the cosine of pi over 3, which is 1 over 1/2. Okay, and here's where we're going to go back to like your 5th grade, 6th grade, well, probably 6th, 7th grade math. If it's 1 over 1/2, that's where we're going to keep it, change it, flip it again. So that's going to make it We're going to run out of room here real quick. So that's, let me put that over here to the side. I need that. Actually, just stretch it here. So it's going to be 1 times 2 over 1. If we keep change flip, that makes it 1 times 2 over 1. That's just 1 times 2, so that's just 2. There you go. Well, maybe that's not too bad. Okay, not bad. All right. So for the next one, if we do the secant of pi over 2, again, we know that's going to be 1 over the cosine. We're going to skip this middle step so we don't run out as much room here. The cosine of pi over 2 is 0. Uh-oh. So that's 1 over 0. That's going to be undefined. Okay. Now here's where we're going to not write down as much because, again, we need a little bit more room with this one. So for the next part, if we do the secant of pi over 6, we need 1 over the cosine value, which is square root of 3 over 2. So that's 1 over square root of 3 over 2. Okay, so if we keep it, change it, and flip it, that's 1 times 2 over the square root of 3. Okay, but with 1 over, when we do it's 1 times 2 over square root of 3. The 1 time is not going to bother, so that's just 2 over square root of 3. That one you have to rationalize it. So again, we're going to do our shortcut. We're going to move the square root of 3 from the bottom to the top. That 2 that was on the top stays there. So we'll move the square root from the bottom to the top. On the bottom, we take the square root off and just leave the number. So that is 2 square root of 3 over 3. That doesn't simplify. So that would be your answer. Okay. Now, and again, I'm just going to kind of fold this back so we don't have to worry about the stuff that's in the middle. Because again, if you're doing secant, we don't need tangent. We don't need sine. The only value we need is, and y'all don't have to do this, we just need the cosine value. So if we had this little chart that's here, we're just going to fold this thing back so that all we have is the cosine value because we just need 1 over that. So if we need the secant of pi over 4, that's going to be 1 over square root of 2 over 2. Again, if we keep changing flip, it's kind of the same scenario we had back here. It's going to make it 1 times 2 over the square root of 2.
Do I hear birds?
Somebody share screen.
Oh.
Okay. For that part, we're going to move the square root from the bottom to the top. On the bottom, we're going to leave the square off and leave that with just a 2. And if we do that, the 2's cancel. And we get just square root of 2. Yeah. So finally, for the number 5, we get one that's easy, kind of like number 2 was. This case, it's 1 over the cosine value. It's 1 over negative 1. There we go. Nice and easy. That's just negative 1. Yeah, that's a nice one to have. Okay, so for 330, it's 1 over square root of 3 over 2. But again, you don't have to reinvent the wheel because we did that same number right here. We know that answer is going to be 2 square root of 3 over 3. And that's where this chart comes in handy because you don't have to keep redoing these numbers. When we get to the next one, at 45, it's square root of 2 over 2. But again, we just did that same answer here. That answer was just square root of 2.
Now, if we get something like this on the test, and we already did it like we already did this earlier, do we have to rework it?
No,
or
you don't.
Okay.
Yeah, if you've already got an answer that you've done that you knew was that one, and you look back and it's the same answer, then yeah, you just go, oh, same answer, boom, I got it. Okay. So next one, same thing. This one is square root of 3 over 2, so we know this answer is going to be 2 square root of 3. The only difference is, yeah, this answer is negative, so that means this answer is going to be negative. For this one, 1 over 1, that's great. The answer is just 1. And let's see if everybody can get this one correct. For this one, it's 1 over 0. There we go. Now we're all getting it. That one is undefined. Okay, now here's the good news for cosecant. Because we've done for cosine, it was 1 over, or sorry, for secant, it's 1 over cosine. For cosecant, it is 1 over sine. But here's the great thing. Every answer you need for cosecant, you've already done that for secant because it's all the same answer. So if we kind of, again, we'll kind of just fold the paper so we can cover this up. So if we're doing secant, cosecant, all we need is the sine values. So I'm going to cover up the, actually I'm just going to cover up the tangent values for a minute. Yeah, so we fold this one back. We're going to leave the answers for secant here, but for sine, for cosecant, we need 1 over sine. So when we do cosecant on this one, it's 1 over the sine value. The sine value is square root of 3 over 2. So we just kind of cut off the cosine value. It's 1 over the square root of 3 over 2. But guess what?
We did it already.
We did it already. It's right there. There's 1 over square root of 3 over 2. We know this answer is going to be 2 square root of 3 over 3. Every answer that you need for cosecant, you already have it because it's the same values. It's just picking a different one. So when we do the cosecant of pi over 2, we need the sine value. It's 1 over 1. So that's just 1. Boom. There we go. For cosecant of pi over 6, there needs to be 1 over the sine value of pi over 6. That's 1 over half. And we did that one. Where was that one? Oh, that was up here. That was the very first one we did up here. That's 1 over half. We know that answer is going to be 2. So every answer that you can possibly look for cosecant, that number is already here under secant. So you don't have to keep reinventing the wheel on this one. You've already got all the answers for this one. Okay, so we're not gonna do the rest of these because every answer here is just a repeat of one of these answers down here. Now we can pick a random one if you want to. So number 8, sure. If we do number 8, we need 1 over sine. That's 1 over 1/2. But again, we just did that back here. We know that answer was going to be 2. Because there's no radicals in that question when you plug in the numbers so there's not going to be any radicals you get back here. So any number you pick through here, the answers are already here. So if you've got the answers for secant, you've also got all the answers for cosecant because they're the exact same answers just depending on which number you pick there. Okay, and then the last one we have to do is cotangent. Okay, and for cotangent, again, I'm going to cover up the secant and the cosecant answers. Because for cotangent, all we need is to take the sine and the cosine and look at those answers. Okay, so when we do cotangent, cotangent is cosine over sine. So when we do the cotangent of pi over 3, that is 1/2 over the square root of 3 over 2. But here's the oh joy moment. If you look under cotangent, if you flip over to tangent, guess what? It's the exact same answers. So we just to let you see. So if we need 1/2 over square root of 3 over 2, there's 1/2 over square root of 3 over 2. That answer is square root of 3 over 3. So I don't even have to work it out. I just look at my little cheat sheet here, and I've got the answer of square root of 3 over 3. Boom. There you go. So every answer under cotangent, you've already got the answers under tangent, so you don't really have to work them out. You just need to look at your cheat sheet here and find the answers, and then you've got everything you need. What? Yeah. Okay, so let's do another one here. So if we do cotangent of pi over 2, that needs to be cosine over sine. That is 0 over 1. 0 on top. The answer is 0. There we go. Now we get it. Okay, if we have to do the cotangent of pi over 6, that is square root of 3 over 2 over 1/2. But again, don't reinvent the wheel, because if you look at the chart we've already got here, we already have square root of 3 over 2 over 1/2. That answer was right here. That answer was going to be square root of 3. So no, that answer is going to be square root of 3. Because we just flipped back over to cosine. Because cosine, we needed square root of 3 over 2 over 1/2. If we look back over here, we already had that answer right here. So the answer was just square root of 3. Okay. So for on number 4, what happens when you put the same thing over itself? Cancels out. Answer's 1. There you go.
For tangent,
Uh-huh.
it's sin over cosine?
Yep.
Okay.
And then for cotangent, it's cosine over sine. Yep. Okay, so every answer that's on here for cotangent, you've already got it listed for tangent, because you're just going to flip it upside down. So instead of having square root of 3 over 2 1/2, you would have, where'd it go? Yeah, right here. 1/2 over square root of 3 over 2. But we already worked that out. We know the answer is square root of 3 over 3. Okay, so we're not going to fill this out because all these answers, we already have all the answers there. So there's no need of kind of working all those out when I go through it. Question. Mm-hmm. Yep, same answer as this one, but but the answer would just be negative. So you put a negative on the outside and then 3 on the inside. There you go.